Okay, so today I will talk about the pack that I ordered from Banggood. This is made of 4 small LiPo batteries that I will use further on. So I will talk about the unboxing, show the unboxing, and then make some tests regarding the status when they arrived. Then how much I can charge them and how much I can discharge them, how balanced they are, and what's the voltage plot during the discharge. So when I received it, there were in 4 small boxes. One of them was bigger than the others, but the batteries were the same. It came with a user manual and a few stickers, and the user manual is quite comprehensive with all the useful informations. First of all, I made a small test to check how much they were charged for the storage and if they were well balanced. So basically they were charged at 50%, which is fine regarding the user manual. And regarding the balanced, 10 millivolts of difference between the 2 cells in the first battery. The second one is also at 50% and 15 millivolts. Here the third 11 millivolts, and the last one is interesting because the 2 cells were perfectly balanced. So basically it fits what the user manual said. The battery is quite lightweight and small, so it will fit perfectly in my small 90 drone. Okay, so from that point I will charge them using a parallel charging board. So it will take about half an hour because I charged them at 1C to not overstress them. And 4 batteries, they were half charged, so I can expect to give them about 1000 milliamps hour, and that's exactly what my charger was able to give them. So here it seems to be good. Now that they are charged, I can now check that they are well balanced. The charger is supposed to make some kind of balancing, but well, with a paraboard it sometimes can be not so balanced. So here this first one is fully charged and it is quite well balanced with only 8 millivolts of difference between the 2 cells. Well, I'm wrong here, I should return. Yes, okay, that's fine, it's better. And this one is also fully charged with 9 millivolts of difference, which is quite small. And the third one is fully charged also 7 millivolts, so it's balanced. And the last one should be fully charged. Let me check. And it is also well balanced, so everything is fine, the batteries are well balanced. So now let's try to discharge them. They are given for 80C, so it can be quite huge, but I will never use such an amount of amperes, so I will just discharge them at 1C to check. And I will set the cutoff at 3 volts according to the minimal given in the user manual. So let's go for it. It's currently running, so it's at 1C, and well, let's change that and increase to 2C. I want the discharge to take about half an hour, and I expect to drain the whole capacity of this battery, so approximately 550 milliamps hour. Let's see. So it's currently running. We're at the beginning. This is an electronic constant current electronic charge. So well, we are near the end. What do we have? Okay, we can see the voltage decreasing quite fast, so it's really the end, and it will probably stop very soon. Yes, it is collapsing, so it will stop here. Okay, so we can see that we managed to drain 545 milliamps hour, which is quite close to the 550 milliamps hours. So it's nice, but of course the cutoff was at 3 volts, and I assume that I cannot fly until my batteries reach 3 volts. We will check that a little bit later with the voltage plot. So the second battery, this one, you can already see the result at the top of my screen. I will run the exact same test with a cutoff at 3 volts per element per cell and 2C. So let's run it. It runs, and half an hour later, okay, 563, well, amazing. So we have more capacity than by design. So it's quite a good news. Even if I use a cutoff a little bit higher, I can expect to have a good capacity. Let's make the test with the fourth one. So we will see if the whole pack is consistent. And this time I connected my oscilloscopes to trace and to make a plot of the voltage during the discharge. So let's go for it, and it runs at 2C with cutoff at 3 volts, and at the end voltage is collapsing and we reach 546 milliamps per hour. Okay, that's good. It's very close to the specifications once again. And if we have a look at the voltage trace, we can see that the voltage is quite stable until it reaches 3.5, 3.3 volts, and then it collapses. So let's test the fourth battery. So the voltage is collapsing at 3.5, which is fine. So last one has 541 milliamps hour. Okay, so now with the same trace, I know that at 3.5 I need to come back, and at 3.2, at 3.3 I should be landing. At the end of the charge, it seems to be, well, balanced, and at the end of the discharge, excuse me, well balanced, and the internal resistance is not too high, and it seems to be consistent between the two cells. But, well, it's not completely balanced anyway. And for the second battery, it is a little bit better. It's better balanced at the end of the discharge. And regarding the internal resistance, it is very consistent between the two cells. Okay, so this one seems to be in quite healthy. The last one, no, not the last one, the third one is very well balanced. Okay, that's fine. And regarding the internal resistance, well, it's not so good. Well, it's not balanced. The internal resistance is not very balanced. But well, anyway, it's not too bad. And for the last one, we have also unbalanced cells, and the internal resistance is, well, not too bad. It's not very good, but it's not too bad. So at the end, I know that I can use these small batteries to fly, and since I recorded this video, I tried to fly with them, and well, with a very quiet flight, I can fly about 1.5 minutes. Don't forget to press the small thumb up if you liked this video, and it will help me, of course, and you can subscribe if you want to have more content like that. Thanks a lot, have a good day, bye bye.